Hey, my ninja warriors, welcome to yet another power packed session. And in today's session, we are going to cover one shot of matrices. That means all concepts and all PYQs will be covered in today's session. Okay, so this session is of utmost important if you are a serious KCET aspirant. And obviously, do I need to tell you that this session is going to help you in your boards examination as well. Okay, so we are going to cover complete theory, complete concepts in this session related to this chapter, along with PYQs will also be covered. Okay, so there will be a lot of students who will be asking in comment session whether this session is enough for KCET, also that I have not studied anything from this chapter. I am a beginner for this chapter, can I attend this lecture? So yes, we are going to start from the very scratch. Even if you do not know anything about matrices or determinants, you can attend this lecture, you can rely on this lecture, and after this lecture you will be able to solve all previous year questions and all related questions from your KCET curriculum. Along with that, you'll be able to solve your board examination questions as well. Okay, because in mathematics there is not much difference if I talk about the solving part, because there is like the theory is similar, just the level of questions are different, right? Okay, so on this note, let us start today's session. And also, if you are coming for the very first time on this channel, and if you don't know me, this is my brief introduction. My name is Namrata, and I have over more than 10 years of teaching experience in both online as well as offline. I have been training and mentoring students across the India, and yes, I have been producing top all India ranks, got 1,000+ selections in various IITs, NITs, and triple ITs, other various reputed colleges as well. Okay, now the agenda, right? Like the major agenda which you always ask me in the chat box, that ma'am, what is the weightage of this chapter as far as your KCET concerned, right? So over here I have written matrices and determinant. You all know that these two chapters are linked chapter, right? So matrices and determinants, if I talk about, you can expect 6 questions from this chapter alone, like from matrices and determinant alone in your KCET examination 2025. Okay, combine, because you know they are interlinked chapters. Sometimes it is very difficult to differentiate whether this question is from matrices or determinants. Okay, so today we are going to only focus on matrices, and the next session is going to be about determinants. So if you cover these two one shot, you will ensure that 6 question 100% you will be able to do in your KCET examination. Okay, on this note, I guess we are ready. And also one more thing, try to make your own notes while attending this lecture. Okay, so I hope that you are following that while doing the complete one shot. This is my ninja tip, you can say. Okay, so now without wasting any further time, let's get to the business. Okay, all right, so now definition. Now, if I see this, let's understand what is a matrices. Okay, how does a matrices looks like? So, matrice is nothing but a decoration, you can say, ma'am. Decoration, yes. Decoration, by decoration, I mean it is a rectangular arrangement of some numbers. Okay, so if you ask me, let us say this. Let me just take one example of matrices. So, this is a rectangular arrangement of m into n numbers. Okay, so m into n, so let me just write it as 3 cross 2. Okay, so 1 0 1 3 2 7. Can you see that rectangular arrangement of 6 element will look like this? This is just an arrangement. Unlike determinants, this is not a value, because determinant, what is the difference between matrices and determinant? Determinant is a value, but matrices is not a value, right? It is an arrangement, the placement. Okay, we have just written the numbers. All right, yes. So A is equals to this 3 cross 2. Okay, so in matrices now you have to understand with which letter we denote matrices. So we have to denote matrices by capital letter, that is first thing. Second thing, that you can see a square bracket, and you can also write it as a open bracket as well. You will see a lot of this in books as well. Both are fine, but we are going to use mostly the square bracket. This is more convenient, this is more frequently used. Okay, right? Now two things come along with matrices. Number one is row, number two is column. Now ma'am, what is a row, what is a column? See, over here the horizontal ones are row. Okay, the horizontal ones are row. Hold on, this is wrong, let me just correct this. Okay, yeah, the horizontal one is your row. So how many rows are you able to see over here? So ma'am, this is your row number 1. This is your row number 2. So row 1, row 2. We have got 2 rows. The vertical ones you are seeing is column, because I have seen majority of the students have a lot of confusion. What is a row? What is a column? Okay, don't get confused. Horizontal, row. Vertical is column. This is C1, C2, C3. So we can see 3 columns. Okay. Now, one more term. Now you don't know the number of rows, 2. Number of columns, 3. After this, you have to understand that we have another terminology which we call it as order of a matrix. What is the order of a matrix? Order of matrix is simply number of row cross number of columns. So here number of row is what? 2. And number of column is what? 3. So order of this matrix is not 3 cross 2 but 2 cross 3. That is why I thought, oh, I have written it incorrect. Okay, so now you know what is the correct order of this matrix. Okay, now if I just want to go in general, okay, not the specific, in general. So can you see this? This looks a little bit complex, okay, but you will understand it better. Okay, so can you see this? This is a matrix A again, and it is having how many rows first of all? So I can see this is first row, this is your second row, see 1 1 1, so first row, then this is your second row, then third row, and finally we are having mth row. So how many rows? M rows. Okay, and how many columns? So first column, second column, third column, and nth column. Can you see this is nth column? So this is n. So what is the order of this matrix? Order of this matrix is m cross n, my dear students. Okay, so I hope now you know what is a matrix. Number one, what are rows, or what is a row, what is a column, and along with that, what is the order of a matrix. Okay, now one more thing I would like to tell you about this. See, yes, one more thing. Okay, so now you know this. Now I am taking 3 cross 3 matrix. Can I take 3 cross 3? Yes, ma'am. So 3 cross 3, let us mark it as A matrix. Now there is one specific way of representing the elements of a matrix. Let me tell you, very specific. Okay, what is this, ma'am? So the very first element of this matrix is residing in row number 1. So this is your row number 1 and column number 1. Row number 1, column number 1, that means A11. Now row number 2, sorry, row number 1, column number 2. Can you see? So still A12, this is A13, right? A11, A12, A13, A21, A22, A23. A31, A32, A33. Now you understand that these numbers which are written right here are very important. There is some significance. So if I just mark any random, okay, so if I just pick this, A31, this 3 is representing number of row and 1 is representing number of columns. So if I say A31, you clearly should remember, okay, 3, 1, third row, first column. Ma'am, I know the position. I can imagine it. Okay, it should sit straight in your brain, that 3-1, A31. Okay, so if I just tell you A23, ma'am, hold on, A23. So second row. So second row, can you see this is your second row? But third column. Okay, so now you understand Aij. is what? Element residing in ith column and, sorry, ith row. What am I doing? Ith row and jth column. Are you getting my point? This is very important. Aij and Aji are two completely different. You can't be just randomly, okay, A32. So you can't just interchange row and column. You have to be very specific. The first number is representing row, second is representing column, okay? So yes, element of a matrix is denoted by Aij, which is present in ith row and jth column, okay? And the total number of elements, so we know. Total number of elements, how will you calculate? Basic maths. So here 3 rows, 3 column, 3 3s are 9. So 9 elements will be able to see. Number of elements is number of rows into number of columns, okay? And again, I have already told you that order of any matrix is number of row. So here number of row is m and number of column is n. So m cross n will be the order of this matrix. So I guess this was all about the terminologies related to matrices, and now we will talk about one question, because I know in mathematics whenever I teach theory, you guys are like, okay, I'm leaving, right? So in matrices, I guess in whole mathematics, if I tell you that one chapter which is having majority theory, one theoretical chapter, it is that chapter. Especially in the beginning, especially in the 30 minutes or 40 minutes, you have to invest in the theory of matrices. For all of those people who are like, okay, 15 minutes, more than 15 minutes theory I cannot handle, this chapter is not for you. And trust me, this is a most scoring chapter. Theoretical, but interesting, okay? Some theory, if you understand, then only you will be able to solve questions, okay? So here comes the question: if a matrix has 12 elements, okay, then what are the possible orders it can have? Okay, 12 elements, think about it, okay? So what I'll be doing is I'll be thinking about it. 12, how will you get 12? See, order is m cross n, and if you multiply, you will get mn, so total elements is mn, okay? So here 12 elements are there, so we have to set our order in such a way, okay, such that we'll get 12. So it can, case number 1, 1 cross 12, that means 1 row and 12 columns. Can this happen? Yes, absolutely. Second case is going to be 12 cross 1, that means 12 rows and 1 column, okay. Third case is going to be now 12 1 1 12 2 rows and 6 columns, and fourth case will be 6 rows and 2 column, okay ma'am. Next, fourth, fifth and sixth, so it is going to be now 2, so 3 4s are 12, 3 rows 4 columns, 4 rows 3 columns, that's it. I'm not able to think about anything else apart from that. So there will be 6 orders, right? So answer to this question will be 6 orders. I know that you must be thinking, ma'am, how are you going to create that matrix? Don't you think this is like something very 1 cross 12, 1 column, sorry, 1 row and 12 columns. So 1 row, that means this, and 12 columns. So this is row number 1, column 2, and all the way up to column 12. So basically 1, 2, 7, 0 and 4, like this. This is a matrix, right? This can be a matrix, so, and so on. 3 cross 4, 4 cross 8, 2 cross 6, like that. So I have created one such matrix for you. I can see, you can imagine the next matrix. Okay. All right. Now next problem related to Aij, that I already told you, elements, okay. Construct a 2 cross 3 matrix whose elements are given by Aij. And the formula is already given. Now this is very important for your board's examination as well. Understand, 2 cross 3 matrix. How come 2 cross 3 matrix will look like? So it will have row number 1, row number 2, but it will have column 1, column 2, column 3. So that matrix will look like this, okay. This is your A. Now I can remove it, okay. It is just to tell you that how to imagine. Okay, A is equals to this. So now this is A11, A12, A13, A21, A22, A23. Right? 6 elements you can see. Now you have to understand that all the elements will be calculated by this formula. To calculate A11, you have to put I and J both equal to 1. Right? Put I and J both equal to 1. So this is I is 1 plus 2 into 1, 2 upon 3. So 3 by 3, you are going to get 1. A12, A13, okay? A12. Now I is 1, J is 2. So 1 plus 2, 2s are 4 by 3. So this is your 5 by 3. And A13 is 1 plus 3, 2s are 6 by 3 is equals to 7 by 3. Okay. So yes, we can put the value. We can start creating it. So 1, 1 is 1, then 5 by 3 and then 7 by 3. Correct? 5 by 3 and 7 by 3. Now A21. For A21, you have to put I is equals to 2 and J as 1, right? I 2 and J as 1. So 2 plus 2 ones are, so 2 plus, so this is 3 by 3 again. So this is 1, A22. Now both are 2. So 2 plus 4. 2 plus 4 by 3, so that is 6 by 3, 2. And A23 is your, the moment you put J is equals to 3, it is a 6. 6 plus 2 is 8, 8 by 3 directly. So 1, 2 and 8 by 3. 1, 2 and 8 by 3. This is how you can construct this, okay? Although this is not like very important for KCET, this is very basic for KCET, but this is important for your boards, second PUC, important for second PUC, okay? 1 marker question you can get, important for second PUC. Okay, all right, yes, cool. Okay, all right, now we are having a lot of loads and loads of definition, so be prepared, huh? Like till 10-15 minutes, no question, only theory. Because if you don't understand theory, if you don't understand terminology, how are you going to answer any questions, right? If somebody tell you there is a column matrix, you don't even know column matrix, then how will you solve the question? So be patient and listen to the theory nicely, okay? All right, so types of matrix. First is a row matrix. Row matrix, a matrix having a single row, okay? So let me just give you the example. It is so obvious, right? It is also called as row vector. So row 1 and let's see column 3 or 4. Okay, so this is your A matrix. Okay, so A will be what? It will look like this. Horizontal matrix. Okay, so this is 1, 2 and 3. 1 cross 3 is the order. 1 cross 3. Column matrix. Now you know the drill. Okay, B matrix will be having single column, but it can have more than one row. Okay, so 1, 3, 7 and 9. Can you see how many row? Row number 1, 2, 3, 4 and so 4 rows but 1 column. This is your column matrix or column vector also you can say. Okay, so I guess these two definitions are pretty easy, pretty obvious by their names also. We will directly go towards this, which is a zero matrix, or you can call it as a null matrix. Okay, what is a null matrix? What is a zero matrix? Obviously, all the elements of that matrix should be zero. All means all. Okay, if all the elements of that matrix is zero, we will call it as a null or zero matrix. Okay, all right. So yes, this is, let's say, 0, 0, 0, 0, 0, 0. So this is 2 cross 3. 2 cross 3. Okay. All right. Null matrix or zero matrix. I hope that this is clear. Okay. All right. So zero matrix, again definition pretty easy, pretty obvious. Now here comes the square matrix. Majority of our questions, majority of this chapter is based on square matrix. Majority. Okay. So this is very important definition. Now square, what is a square matrix? Understand. Square is something which is like the length and breadth are equal. So in here, square means the number of rows are equal to number of columns. Are you getting it? Number of rows of this matrix is equal to number of columns, okay? So in square matrix, number of rows equals to number of columns. So if I just take it, it is 1, 2, 3, 4, 5, 6. This is a, okay, this is not a square matrix. Hold on. One cross 1 is one such order, 2 cross 2 is another order, and 3 cross 3 is another order, then 4 cross 4 also, okay? So 1 cross 1 is this. 1 row, 1 column, 1 element. 2 cross 2, 4 element, B, B. 1, 2, 5, 7. 2 cross 2. 4 elements, right? See 3 cross 3. 3 rows, 3 columns, 1, 0, 1, 2, 3, 7. And 1, 0, 1. 3 cross 3, correct? 4 cross 4, I will not draw it, but yes. Majority square matrix which we are going to deal in this chapter is 2 cross 2 and 3 cross 3. 4 cross 4, you will not see a lot of 4 cross 4 matrices, okay? Alright. Now, one more terminology which you have to understand, because see, in square, remember the geometry, we used to have diagonal, and we used to have 2 diagonals. But in here, principal diagonal or just diagonal, okay? Whenever somebody is telling you diagonal of a matrix, it is understood we are talking about principal diagonal. So diagonal is something which start from the very first element, okay? So this is your diagonal, 1 and 7, okay? Now you must be thinking, ma'am, this is also a diagonal. No, okay, this is not a diagonal. I mean, it can be a secondary diagonal, but we are not going to talk about that. Like, it is not in our syllabus only, okay? So if somebody tells you diagonal, it is just this only, okay? This is the standard notation. This is the diagonal, okay? It starts from the first element, okay? This, you will not consider it as a diagonal, okay? So diagonal, now understand. Can you just tell me what is the denotation of this? Like this, the element denotation, remember Aij. So ma'am, first row, first column. Okay, so A11. This is your A11, correct? This is second row, second column. Ma'am, A22. Third row, third column, A33. That means diagonal. If you want to create a definition of a diagonal containing the elements A, I, J, but I and J are equal. Basically, all those elements which are sitting in either first row, first column, or second row, second column, or third row, third column are nothing but, and so on, are nothing but diagonal elements, or you can say diagonal, okay? So this is what we call it as a principal diagonal. Now, the moment you understand the diagonal, now, another term comes into the picture, which is trace of a matrix. What is a trace of a matrix? It is closely connected to, trace of a matrix is connected to diagonal, okay? So yes. So suppose you are having this matrix, which is A11, A12, A21, A22. Suppose you are having another, which is A11, A22, A23. This is A21, A22. Sorry. Sometimes I get carried away. 13, A21, A23, A31, A32. Okay. Yes. Trace of a matrix, right? Now, trace of this matrix or this matrix. Trace of this, either this or this. So, trace of this matrix is sum of all diagonal elements. Okay, don't get scared with this summation. Forget it. Sum of all the diagonal elements, okay? So, over here, A11 plus A12. Okay, this is trace of A. And what about trace of B? Because now there are 3 elements in the diagonal. Can you see A11 plus A11 plus A22 plus A33? This is your trace. Okay, this is not a very difficult topic. It's just that if somebody is asking you trace, so you should be immediately think about, okay, trace means sum of the diagonal elements. And to know sum of diagonal elements, you should know diagonal elements. To know diagonal elements, you should know diagonal is this and not this. Don't make this mistake, okay? All right, I think yes. And now here comes the types of matrix, okay? Types of matrix. Types of matrix. Now, types of matrix, obviously we have studied, there is a square matrix. And we are going to deal with square matrix a lot in this chapter. I already told you this. Square matrix are of two types. First one is diagonal matrix. Can you see? Diagonal matrix. Oh, ma'am, diagonal matrix. What is a diagonal matrix? What is a diagonal matrix? Because till now you have told me what is a diagonal. Diagonal matrix is another thing. Understand? Okay. So diagonal matrix is that matrix wherein all the elements which are non-diagonal. See, these are the diagonal elements, right? All the elements which are non-diagonal are 0. Understand now, I am not saying anything about diagonal elements. In my definition, listen carefully. I am not saying anything about diagonal elements. I told you, you asked me, ma'am, what is a diagonal matrix? I told you that all the elements which are non-diagonal are 0. I don't care about the diagonal elements, whether they are 0 or not. Okay. So diagonal matrix, the definition I have already told you. Can you see, this is the definition? I not equal to j. So when I is equal to j, I will talk about diagonal elements. But I and j are not equal. That means we are talking about the non-diagonal elements. Yes or no? So non-diagonal elements should be 0. This is your diagonal matrix. Of course, this is a type of a square matrix. First of all, it should be a square matrix. I hope the definition of diagonal matrix is clear. Now, here comes the scalar matrix. Scalar matrix, now what is a scalar matrix? Scalar matrix may what happens is all the diagonal elements becomes equal. Okay. Obviously, the definition is the same. Scalar matrix is a type of diagonal matrix. Understand? Scalar matrix is a type of diagonal matrix. Scalar matrix is a type of diagonal matrix. That means what? Non-diagonal to should be 0. That is the condition. Non-diagonal, can you see 0? Okay, ma'am. But what about the diagonal elements? All should be equal. A. Okay. So non-diagonal elements should be 0. That is one thing which is written in the definition. And all the diagonal elements should be equal. This is what your scalar matrix is. I hope that this branch is clear. Square, diagonal mein there is a scalar matrix, and one more thing which is very important, that is identity matrix or unit matrix. Unit matrix is again a type of diagonal only. It is a type of scalar only actually. Scalar only, okay. Which is having, now understand, non-diagonal elements should be 0. Non-diagonal is this. This is the diagonal, this is the diagonal, this is the diagonal. Non-diagonal, first of all, let me just make it all 0. And now the diagonal is 1. All are equal, but it is equal to 1. So this is your identity matrix. So this should be a square matrix, number 1. It should be a diagonal matrix, number 2. It should be a scalar matrix also, because scalar, all the diagonal elements, can you see, are equal, but specifically equal to one identity or unit matrix. I guess this branch is clear to you, the definition part. Now this triangular matrix. Okay, triangular matrix. So triangular, square matrix is having two branches, either triangular or diagonal. Triangular is again having two things, two types, upper triangular or lower triangular. What is upper triangular? Now, upper triangular means that elements below the diagonal, that means these three elements should be 0. Hold on, ma'am. Hold on. You are saying in upper triangular, elements below diagonal should be 0. Yes, that is what I am saying. Okay. And in lower triangular, what happens? Reverse. elements which are above diagonal are 0. This is the definition. Understand, I have not spoken about, I have not opened my mouth about what is going to happen with all other elements. I do not care whether they are 0 or not. Okay, so if I just ask you one thing, is this an upper triangular matrix? Yes or no? We will see, pata nahi, no, we don't know because it doesn't look like. But hold on, by the definition, that is why I told you, listen carefully what I am saying. Do not interpret anything. I have told you for an upper triangular matrix, elements below diagonal should be 0. So these three are 0. That's it. Yes, it is satisfying the condition of upper triangular. Is this upper triangular? Yes. Okay, now another question. Is this a lower triangular matrix? Okay. So ma'am, lower triangular, you told us that elements which are above your diagonal should be 0. So above diagonal are 0. Yes, they are 0. So it is satisfying the condition of lower triangular. So this is lower triangular as well. Hold on. Now, you'll be like, ma'am, what is that scam, huh? If you are teaching something and this is something, okay? Okay. One more question. Is that matrix a diagonal matrix? So ma'am, hold on. Let me just rewind and let us just listen. What did you tell? You told us in diagonal matrix, non-diagonal should be 0. You didn't tell us about what should happen with diagonal. Non-diagonal elements should be 0. So non-diagonal. So just remove the diagonal and then check. Everything else is 0, right? We don't care about what is the diagonal. So this is a diagonal matrix as well. Are you getting my point? So this is the point of confusion. Sometimes people create their own definition, but don't do that. Just understand what did I say, okay? Alright, so yes, now one by one, diagonal matrix will refresh every definition. What is a diagonal matrix? A square matrix whose non-diagonal elements are 0, okay? Now another way of representing diagonal matrix, since we know that if it is a diagonal matrix, we know that non-diagonal elements are 0. We are only concerned about diagonal elements, right? So A is equal, suppose if this is the matrix, we will write it as 3, 7 and 9. So it is so obvious that only 3 diagonal elements are written. So 3, 7 and 9. Rest everything can be, obviously is 0. This is the for sure, non-diagonal is 0. We are only concerned about these 3 elements if it is a 3 cross 3, right? So we don't have to like write 0, 0, 0 because it's so obvious. So this is another way of representing a diagonal matrix, okay? So this is a diagonal matrix and now we are having scalar matrix. Scalar matrix is a type of diagonal matrix whose all diagonal elements are equal, okay? So yes, for scalar matrix means it is a diagonal, so that means non-diagonal elements are 0. This means non-diagonal elements are 0. This first thing, and all the diagonal elements are equal, right? So this is diagonal elements are equal. So that means k and non-diagonal make it 0. This k can be anything. There is no condition for k. Okay, this is a scalar matrix and now we are having unit matrix, or you can call it as identity matrix. So this is a type of scalar matrix. That means non-diagonal elements should be 0 and rest diagonal elements are equal and is equal to 1. Unity, identity and unit. Okay, it depends what is the order. So one more thing, this is order 3. 3 cross 3 means what? Order 3. Okay, so this is I3. We will write it as I3. If somebody asks you what is I2, so that means order 2. 1, 1, 0, 0. That's it, order 2. I1 is what? Just 1. I4 and so on. Okay, and In is nth order. So this definition is also clear, I hope. Now upper triangular matrix, you can see upper triangular matrix is this, okay? So upper triangular means all the elements below the diagonal should be 0, right here. Can you see this? And lower triangular means all the elements above diagonal are 0. We don't care what is happening below or in diagonal, okay? So this is upper and lower matrix. And now we will talk about algebra of matrix, okay? Algebra of matrix. So first of all, algebra of matrix may, before this addition and subtraction, you can see, I would like to tell you that what happens when two matrices are equal, or when exactly two matrices are equal. What do you think? Two matrices are equal. Let me just write it over here. Okay, let me just write it over here. Yes, or here. Okay, equal matrix. Equal matrix. Two matrices are equal if, first thing, order of both are same and corresponding elements is equal. Okay, corresponding elements are equal. So first thing, order should be same, then corresponding elements should be same. Let's do one question and understand, okay? So yeah, A is sin theta. A is this matrix which is clearly 1, 2, 3. So there are 3 rows and 2 columns. 3 rows and 2 columns. Here also 3 rows and 2 columns. So A and B both are having same order. And find theta so that A is equals to B. Now they are giving us that A and B both are equal matrix. That means what? Okay. So if A and B are equal, then the corresponding elements can be made equal. Sin theta is equals to 1 by root 2. Okay, this equals to this. 1 by root 2 is sin theta. It will give me same result, okay. Minus 1 by root 2 is cos theta. So that means cos theta is minus 1 by root 2. Cos theta is cos theta, okay. Cos theta is cos theta, and tan theta is minus 1. Obviously, if you divide these two, tan theta is going to become minus 1. These three information I am right away getting over here. Now, let us talk about that ASTC rule. ASTC, okay. First quadrant, all are positive. We don't want that. I want my cos and tan to be negative. Cos and tan to be negative. So, in fourth quadrant, cos is positive. Fourth quadrant, not possible. So, my theta will belong to, okay. So, in second quadrant, sine is positive. In third quadrant, sine is negative. So, third quadrant also I cannot take. Also, in third quadrant, what happens? Tan is positive. I want my tan negative. Tan and cos both are negative in second quadrant. And since you can see 1 by root 2, the values are multiple of 45 degree, pi by 4. So we can say if this first quadrant pi by 4, second quadrant 3 pi by 4. So clearly theta is 3 pi by 4, guys. So option B is check, check, check. Check, check, mic check. Check, check, option check, 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 question check. Done, 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 done. What do you think? Okay, easy question. Yes, are you able to do it? And now we will talk about how to add two matrix, how to subtract two matrix. So first of all, again, if the order of both the matrices is same, then only we can add, then only we can subtract. And how to add, how to subtract, it is very easy. Just add the corresponding elements. Just subtract the corresponding elements, right? So we can do that right away. Yes, okay. Yes, so I think I'm not touching that. We'll directly go into the problem solving zone. Okay, I will not explain it right here. I'll give the problem and explain it. So you'll understand how to add and how to subtract. Okay. Now, algebra of matrix. Okay. So if you are given with two matrix A plus B. Okay, so it is as simple, 3 plus 2, just like in your normal mathematics, right? 3 plus 2, 2 plus 3. So this is commutative. A plus B is B plus A. So matrix follow the law of commute. Okay. And then subtraction, though we know 3 minus 2 is not equals to 2 minus 3. So again, A minus B and B minus A cannot be equal. Also, if you add anything to 3, you will get 3. So this is what? Additive identity. 3 plus 0 is 0 plus 3, which is equals to 3. So A plus 0, this is not 0, this is null matrix. It is denoted by O. Okay, or you can call it as, this is O. A plus null matrix plus A will give you A, and this is your additive identity. And if I talk about this, A plus minus A, this is additive inverse. What should I add in 3 to get 0? So you have to add minus 3 in 3 to get 0. So A plus minus A is a null matrix, just like that. So this is your algebra of matrix. Very simple, quite intuitive as well. And now multiplication of a matrix by a scalar. Now this is something which is different. This is something which might be a problem when it comes to matrices and determinant. Okay. So we'll study indeterminate, that is going to be a different one shot, different chapter. But in matrix, so suppose you are having this A matrix is right here, which is 3, 7, 9, 2, 5, 7. And let me change the color, I'm not liking it. This was good, right? A is equals to 3, 2, 7, 1, 4, 2, 0 and 0, 0, 9. If you want to multiply any constant k, suppose 2a, so what you have to do is, in matrix multiplication with scalar, you have to pick every element and multiply it with 2. Catch every element, okay? So you multiplying 2 in this matrix, so 2 will be multiplied each and every one. 3 2s are 6, then 4, then 2, everything will be multiplied with 4. Okay, all right. Unlike determinants, in determinant what happens, that we will see in next lecture. But to give you a hint, if you want to multiply any constant in determinant, any scalar in determinant, you have to decide whether a single row or a single column. So you have how many rows, how many columns? If I talk about 3 cross 3, so you have either row 1, row 2, row 3, or column 1, column 2, column 3. So you have 6 options. So you have to pick one from 6 options. Suppose you decide I'll multiply with row number 1. So you just only multiply with row number 1, 2, 2, 2. That's it. Or you decide you multiply with, or you decide you multiply with this. Or you decide, no, I don't want to go with row. I want to go with column 1, column 2, column 3. Either of anything. Okay, that we will understand. Don't worry, do not get panic. Now we are having a few questions which will help you in your KCET definitely, because I have seen and I will show you. I have PYQs as well. I am waiting. I am patiently waiting because I want you to teach everything, and then I'll give you a question and I'll watch you. I'll be like, oh, let's see whether you are able to do it or not. And I'm very sure if you understand this lecture nicely, you'll be 100%, you'll be able to solve KCET questions, because KCET level, you know, it is not that tough. Okay, it's just that you have to solve questions on time and you have to build your exam test solving skills is like something. Okay, so that you attempt each and every question. Okay, so this question says, if this matrix plus this matrix is this, then X is equal to, okay. So this is a simple sum of two different matrix, okay. So corresponding elements, I'm going to add this plus this. So my summation will be x square plus x plus 0. Second will be x minus 1. 3 minus x plus 1. 2 plus x. This is your final addition matrix. Order is same, that is why we can add it. And on the right hand side, we have 0, minus 2, 5 and 1. Now these two matrices are equal. When two matrices become equal, the corresponding elements we have to make it equal. So that means first element equals to first element. So first thing is x square plus x equals to 0. Second is x minus 1 is equals to minus 2. Third is, this is 4 minus x is equals to 5. And fourth is, all four things should satisfy. It should not have happened that, okay, ma'am, I will equate this, I will get the value of x. No, hello. If these two matrices are equal, every element from this matrix should be equal to, corresponding element should be equal to this, okay. So we have to take care of each and everything. So fourth is what? 2 plus x is equals to 1. Now one by one, just tell me the values of x. Let's see that if all four equations is pointing towards single x or not. So from here clearly x plus 1 equals to 0, x equals to 0 comma minus 1. What about this? X equals to 1 minus 2, so minus 1. Okay. So I can see x equals to 0 is not your answer. Because if you put x equals to 0, obviously first element will match. But the moment you put x equals to 0 over here, this will become minus 1 and this will become minus 2, no equal. So that is why option B to definitely gone. Obviously, answer is between 0 or minus 1. So 1 and 2 is, minus 2 is also gone. Option A is clearly correct. It should be. We are not sure. We are doing it. What about this? Can you see from here also I am getting x equals to minus 1 and from here also x equals to minus 1. Every equation, all four equation is pointing towards option A. So option A is absolutely right, guys. I hope that this is clear. And here I am with another question. Okay. And this question tells me that A plus B is this, A minus 2B is this, and I need to know the matrices A and B. So it is just pure equation solving. Okay. Just forget about this. Just think about x plus y is given and x minus 2y is given. What would you do? Tell me. So ma'am, it is very easy. If you want to get the value of b by elimination, just subtract these two equations, right? So what we will do is a plus b is given to you, which is 2 minus 1, 1, 3, minus 3, minus 2. And a minus 2b is also given, which is minus 2, 1, 3, minus 1, 4, minus 2. This is first and second. Now if you subtract first minus second equation, subtract first and second, what will you get? You will get a plus b minus a minus 2b. Correct? On the left hand side, this minus this. On the right hand side, you just have to subtract. So 2 minus minus 2. Ma'am, 4. Minus 1 minus 1. Ma'am, minus 2. 1 minus 3. Corresponding elements. Minus 2. 3 minus minus 1. 4. Minus 3 minus 4 is minus 7. Minus 2 minus minus 2 is 0. And if you understand what is happening, A is getting cancelled out. B, so this is actually 3B, which is going to give you this, which is 4, minus 2, minus 2, 4, minus 7 and 0. Now you have to divide by 3. Now understand, multiplication by scalar is same as division by scalar. So what you have to do is you have to divide both sides by 3. So 3 is gone here, 4 by 3. This is by 3, by 3, by 3, by 3, and here 0 by 3 will not make any sense, but again 0 by 3. So this is your B. B is done. How to get A? Now to get A, what I am going to do is, I am going to multiply 2 in first equation, right? So what I am going to do is, 2 multiply first equation will give me what? 2A plus 2B. And then add it with second equation. 2 multiply first equation plus second equation, right? So this is the operation which I am going to perform. So 2A plus 2B. And add it with the second equation, A minus 2B. Right hand side, same thing I am going to do. Multiply 2 and then add. So 2 2s are 4 minus 2. Multiplication of 2 will give you minus 2 plus 1. Multiplication of 2, 2 plus 3. Multiplication of 2, 6 minus 1. Multiplication of 2, minus 6 plus 4. Multiplication of 2, minus 2, minus 4, minus 2. Let me check one more time. So what we are doing is we are multiplying 2 in this and add. 4 minus 2 is 2, correct. Then minus 2 plus 1 is minus 1, correct. Then 2 plus 3, 5, 6 minus 1, correct. Then minus 6 plus 4, minus 2, minus 4 minus 2 is minus 6, that's it. Okay, now if you add on the left hand side, 2b cancel, this is 3a. So this is actually 3a is this. And if you just have to calculate a, so just 3 will be removed, and this is 3, 3, 3, 3, 3, 3. This is your a. Okay, this is your a, this is your b. This is how you solve for a and b. Okay, clear? Give me a big thumbs up if you have understood it. Okay. All right. I guess this is again a board level, not board level question. Yeah, you can get this in KCET. In fact, you have this question in your KCET PYQ, and here comes. How am I not excited? Huh? Here comes something which is a KCET PYQ, guys. Okay. KCET PYQ. So yes, I guess this is a very basic question. Even like the level is even lesser than your previous question. You'll be like, kill it. Now I think before me, I want you to do it because I don't want to touch KCET. I'm like, my students will do KCET. I just want to teach something. I don't want a few questions, but KCET PYQ, and this is the recent one, 2023, you will do it. Okay, so I think this is very basic. Again, x is a scalar which you are going to multiply in this matrix. So if you just do this operation, 3x and 2x. First of all, matrix multiplication with scalar. Now y is again a scalar plus. So this is y into 1 and minus y, correct? This is equals to 15 and 5. Now left hand side, obviously we have to do the matrix multiplication, matrix plus summation, 3x plus y, 2x minus y, 15 and 5. So 3x plus y, now two matrices are equal. Do I need to tell you? 15 and 2x minus y is equals to 5. So 2 equation, 2 unknown, right? Let me just write it like this. You understand it this way better, no? 2x minus y equals to 5. Now to solve this, you have to add both the equation, first and second. So you'll get 5x equals to 20, x equals to 4. So x equals to 4 means b and c are gone. The moment you will put x equals to 4 over here, 4 2s are 8. So this is going to be y is equals to 3. 4 comma 3. So option D is absolutely correct. And also you can just substitute 4 and 3, also hit and trial, you will get your answer. So yes, 4 2s are 8 minus 3. This is 4 3s are 12. 12 plus 3, 15. Yes, option D is satisfying both the equations. Okay. So I think it is an easy peasy, absolutely doable question. Like if you skip these type of questions, there's something wrong with you. You have not attended lectures carefully. Okay. Sometimes we do that. Okay, we know that. Don't do that. Don't take anything lightly. Okay. All right. Another we have this. Now properties of scalar multiplication, although we are aware about it, but just one more time. Okay. So A and B are two comparable matrix. Okay. So obviously A and B are comparable matrix of order m cross n. So now again, if somebody is writing 2A, suppose 2A or A2, this is same only. There is no difference in this. Point number 1. If you have to multiply this constant in sum of two matrix, again we did that. We did that. Do you understand? We did that already, right? I multiplied 2 in this, 2A plus 2B. So the same thing which we have already done, same theory, quite intuitive. So this is also done. 2a plus b is 2a plus 2b. Okay. And yeah, these two properties are also quite intuitive. Okay. So you can see if these two are constant, K1a and K2a. That's it. Okay. All right. Clear? So properties of scalar multiplication, I don't think so much time I need to spend on these properties, because these properties are quite intuitive. And here comes something which carries utmost important for your KCET and for your boards as well. What is that, ma'am? That is multiplication of two matrix. Okay. So multiplication of two matrix is something you should be very careful with while understanding. Okay. And also one more thing, we only study theory once. Okay. But study like that, study theory like that you don't have to like redo it. It should be like printed in your brain. Okay. All right. Multiplication of two matrix. Okay. Now product of two matrix A and B will exist only when number of column is same as number of rows. Now understand what I'm trying to say over here. Multiplication of two matrix. Okay. Hold on, give me a moment. Yes, suppose I have a matrix A which is 1, 2, 3, 4, 7, 0. And I am having a matrix B which is 1, 2, 3, 7, 0, 1. This is obviously 3 cross 2 and this is 2 cross 3. Okay. Now understand. See, suppose you are in a school. Okay, you take admission in your school, and obviously everybody is of your age. Everybody is of your age. So what do you think? Like, can you make friends with everyone in your school? No, right? It depends. Although they are same as your age, studying same thing, like your life is same, almost similar, like your curriculum is similar, but still compatibility is not there with everyone. Same. Multiplication of two matrices is not possible just because they are matrix. No. When the multiplication is possible, understand. So multiplication is possible when number of column of first matrix should be equal to number of row of second matrix. Understand. Number of column of first matrix should be equal to number of row of second matrix. That means 3 cross 2, number of column should be equal to number of row of this. Okay, that is first thing you should understand. Then only we can say that product can be done, like multiplication exists. Otherwise multiplication will not exist. Okay, all right, that is one thing. And now how to multiply? Now understand. Now AB exists because 2 and 2 same, right? So find the value of AB now because it is existing. How to calculate multiplication? Understand. So now what I'm going to do is row 1 is getting multiplied with column 1, and I'm going to get my first element. How? Row 1 will be multiplied with column 1. So this is your row number 1 horizontal. This is your column number 1 of matrix 2. So row 1 of first matrix will get multiplied with column 1 of matrix number 2, and it will be written down as first element. Okay, so row 1. Row 1 is fixed. Row 1, column 1, first element. Row 1, column 2, second element. Row 1, column 3, third element. So row 1 is fixed, okay. Then row 1 got multiplied with column 1, column 2, column 3. Then row 1 is done, overused, used everywhere. row 1, then we will come to row number 2. Row 2 will get multiplied with, again, column 1, column 2, column 3, same. So I'll get this, 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 okay. And then last, row 3 will get multiplied with first column 1, then column 2, then column 3. So this, this, this. Okay, let's do it so that you understand it better. Row 1, column 1. So 1 ones are 1, 7 twos are 14. So 1 plus 14 is your first element. Is your first element. Okay. Then second element, what about row 1, column 2? So 2 ones are 2 plus 0. 2 plus 0, your second element. Row 1, column 3, 3 ones are 3 plus 2 ones are 2. So 3 plus 2. Now row 2 and column 2. Row 2, column 2. Sorry, row 2, everything. Yes, row 2 and column 1. So 3 ones are 3 plus 4 sevens are 28. 3 plus 28. Row 2, column 2. 3 twos are 6 plus 0. Row 2, column 3. 3 threes are 9 plus 4. Are you understanding my point? Right? So row 1, column 1 right here. Row 1, column 2 right here. Row 1, column 3 right here. Row 2, column 1 right here. Row 2, column 2 right here. Row 2, column 3 right here. Now, row number 3. Row 3, column 1. 7 ones are 7 plus 0. 7 plus 0. Row 3, column 2. 7 twos are 14 plus 0. And this 7 threes are 21 plus 0. That's it. This is your AB. Okay, this is how you do it. I know that you have to practice at least 4 to 5 matrix multiplication to get the hang of it, for your muscle memory to understand, okay, how it is working. So this is 3 cross 3, 2 cross 3, and finally you can clearly see that your order of the final result matrix is 3 cross 3. Okay, okay ma'am. So one thing I just want to understand, like few things, okay, I would like to ask, which is, okay, so first thing, whenever you will see two matrix, first thing, okay, first question is, AB is matrix is possible or not? Okay, AB multiplication is possible or not? So in this case, AB is possible because number of column of A is equals to number of row of B. So yes, the answer is yes. Second, what is the order of AB? What is order of AB? So order of AB is also, you will understand just by calculating it, but even without calculating the order now, then also you can reply C. I'll tell you the secret. Suppose you see A, you see B. Okay. So number of column and number of row equal, matrix multiplication possible, big thumbs up. Okay ma'am. Now, number of row of first and number of column of second, 3 cross 3 is the order of your final multiplication of matrix. That is third thing. Okay. Now question number 3 is BA possible? My next question is BA possible? Think about it. Is BA possible? Think. KCET preparation is all about thinking, okay. So ma'am, is BA possible? BA, so that means you're saying that first matrix become this, second became this, okay. So B is my first matrix. Now, number of column of first, what is first? This. So number of column of B, basically number of column of B should be equals to number of row of A. Number of column of B is 3. Okay ma'am, 3 should be equal to number of row of A. Okay ma'am, this is also equal. Yes, BA is possible. Oh, BA is also possible. BA is also possible. Definitely ma'am, possible. And if you ask me about the order of BA, it is going to be 2 cross 2. Because again, number of row of B multiply number of column of A will be the order, 2 cross 2. Finally, if you multiply BA, you will get 2 cross 2. What does that mean? That, ma'am, okay. Are you saying AB and BA are two different things? Of course, obviously. So here I'm going to tell you some properties of matrix multiplication, which is this. In general, AB and BA are not equal. Sometimes they can be equal, but in general they are not equal unless it is mentioned in the question. So maybe there may be some case wherein like it is happening that order is also coming same. Okay, so in general you cannot, like, this is not a formula. Just like 3 2s are 6 and 2 3s are 6, not applicable in matrix. Okay, that is one thing. Now also, if you multiply null matrix with any matrix, you will get null matrix directly. And also if you multiply identity matrix with any matrix, identity is like 1. Null matrix is like 0. So if you multiply null matrix, you will get 0. That means null matrix. If you multiply identity matrix, it is 1. So A into 1 is obviously A. So treat it like just 1. Okay. So this is how it is. These are the two important properties. Okay. The third property is quite intuitive again. So if a constant is getting multiplied with K, so understand, you can't change the order. See, understand. AB is there, so AB will be there. You can't write BA in place of AB. It's just that you have to take care of. Okay, now let's do one thing. Let's do one question based on the product so that you get hang of that how to calculate product. You have to, hands-on should be there. In mathematics, nothing will happen if you don't pick the pen, if you don't start solving it. So I'm very sure, I am sure, and I'm very hopeful that you are doing it, writing it. Otherwise, trust me, no matter which teacher comes, no matter which teachers teaches, nothing is gonna work. Okay. All right, A and I. Then the matrix product AI. Okay, so A into I, we have to multiply A into I. So this is 2 minus 3, 1 and 4. This is 1, 0, 0 and 1. Obviously, AI, we know that property I is treated as 1. So this is going to become directly A only. So option C is correct. But still, if you want to practice, you can do that. Row 1, column 1, write it here. 2 1s are 2 and minus 3 into 0. So 2. This is 2 directly. This multiply this will give you what? Minus 3. This row number 2, column number 1 will give you 1. Row number 2, column number 2 will give you 1 into 0, 0 and 4 1s are 4. So can you see that back to A? So whenever you multiply anything with identity matrix, you are going to get A only. Okay. And I know that you might be thinking, ma'am, so fast calculation you're doing, because hands-on practice I have done. Okay. Practice I have did already. All right. Now, there are some more properties of multiplication, although now I think you must be understanding all the properties. See, if you have got product of 3 matrix A into BC, what you can do is, it is allowed that you can just first think about AB and then C. But see, order is not changed. It is associative property. You can't change the order. You can't think A, C, B. No, order is same. Because in matrix multiplication, order you cannot change. That is one thing. Again, distributive property, A times B plus C. So you just multiply. It's just same as 2, 3 plus 5. So this is what? 2 3s are 2 into 3 plus 2 into 5. The childhood property. It is also called as distributive property. It is a left distributive property. Now understand. Because in matrix multiplication, it is important that 2 is coming on the left hand side. You can't just put 2 on the right hand side. It is allowed in normal maths, but it is not allowed in this maths. So see, B plus CA is there. So now BA. Can you see? BA. And this is CA. Okay, the right distributive. Okay, I hope that this is clear. Now A plus B whole square. Understand. A plus B whole square is what? A plus B, A plus B. It is not A square plus B. It is not your usual A square plus B square plus 2AB. Don't do that. Okay, so A plus B into A plus B, okay. A into A is okay. This is fine. A square. A into B is AB. This is also fine. Plus BA plus B square. Now, AB and BA are completely different things. You can't just write 2AB, okay. So understand a plus b whole square is a square plus ab plus ba plus b square. And so same, a plus b, a minus b, you can't write a square minus b square. Understand? A square minus ab plus ba minus b square, you just multiply it same, a into a square, then minus ab, then plus ba. You can't cancel them because these two are different quantities. So yeah, this is it. Okay. Alright, so be careful about the multiplication, especially when it comes to like AB and BA. Now I have got one question which is a KCET question. Let us see how many of you are able to do that. Let us see. Okay, yes, let's do it. A and B are two matrices such that AB is equals to B and BA is equals to A, then A square plus B square is equals to, again easy question. See, start with A square plus B square. Okay, ma'am. So this is your A plus B. Okay. Now A is BA. Understand? This A will be, this A I can write it as BA. So this is A, B, A. Okay, A, B, A plus. This is B dot B. So B is right here and B can be represented by AB. Okay, understood? A is BA and B is AB. Okay, now by using the property, okay, this can be, so ABA can be written down as AB into A plus obviously this also BA into B. So now AB, can you see AB? AB is your B, B dot A, and BA is what? A again. Now this BA is your A and AB is your B. So A square plus B square, I have reduced one by one, little, A plus B, which is matching with option D, guys, matching with option D. Okay. All right. Option D. All right. Now one more question. Let us talk about one more question which is related to matrix multiplication again. Let's do it. Let's solve it. Let's try solving it. Very easy question again. So you have to multiply first matrix, second matrix and third matrix, and this is a null matrix. Okay. So let us just understand. First of all, let's multiply these two, find the resultant and then multiply with this. Let's do that. 2x, 3. This is 1 minus 3, 2, 0. And this is x and 3. So I am interested in first two multiplication. First again, row 1, column 1. So 2x into 1 minus 9. So 2x minus 9. Okay. Row 1 got multiplied with column number 1. Then row 1 will get multiplied with column number 2. So 4x and 3 into 0, 0. That's it. Row 1, column 1, row 1, column 2. That's it. That's it. Okay. So this is the multiplication and x3 is right here. And now you have to multiply. Row number 1, column number 1. 2x minus 9 into x. So this is going to become what? This multiply this. 2x square minus 9x. 2x square minus 9x. So this multiply this. 2x square minus 9x. Okay, this multiply this. And this multiply. So row 1, column 1, that's it. So this into this plus 3 4s are 12x. So this is a 1 cross 1 matrix which you are getting is equals to 0. So this is 2x square minus 3x equals to 0. X is 0 and x is equals to 3 by 2. 0, 3 by 2. So the values of x are, okay, more than one correct. 0 is also correct and 3 by 2 is minus 3 by 2 is also okay. We have a plus sign, so minus 3 by 2. Okay. Getting it? Understanding it? What do you think? What do you think? What is your rough gut feeling? Do you finding it easy? Do you finding it difficult? Do let me know. Okay. All right. Yes. And also at any point of time, if you are having any doubt, you can just write the timestamp. I'll reply it to you. Do not hesitate in writing the timestamp. Okay, even if you find something funny, something not funny, anything, just comment. Okay, this is the only way we can interact. All right. Okay, now power of a square matrix. Now square matrix, okay. So suppose you are having a matrix and that power of that matrix is 0, that is going to be an identity matrix. Just remember, anything raised to power 0 is 1, 3 power 0 is 1. So same as the normal mathematics, same thing we are going to follow over here. Again, this we have done already. Any matrix getting multiplied with identity matrix, but of course matrix multiplication should be possible. At least both matrix should be compatible. You know how, when exactly matrix multiplication is possible. So in that case, you multiply with identity, you will get this. A square is A into A. That we already know. It is quite intuitive. A power n is multiplication of same matrix with itself n times. Okay. And again this thing. Remember, 3 raised to power x, 3 raised to power y. Okay. When bases are same, you can add the power. Same thing is going to happen in multiplication. Matrix multiplication, a cube and a square will give you a power 5. Easy peasy lemon squeezy. Okay. Alright. I think that this is something which you will understand nicely. Okay. Alright. Okie dokie. Again, I'm with a KCET problem. Whenever I'm here with KCET problem, I'll be like, I'm very hopeful that before me, I want you to do it so that you get confidence. See, more KCET problem you will solve, you will feel like, okay, if I'm able to solve this question right now, then it is highly, like, there are positive chances that I'll be able to solve it in KCET examination. Right? Okay. Okay, all right. Now, this A is this A power 4. So, first of all, what we will do is, we will multiply A with A. That is going to give you A square. So, yes, you have to practice matrix multiplication because majority of the students commit mistake in calculating the multiplication. So, same matrix, I am going to multiply it twice. 0, 1, 0, 1, 0, 0. Okay. So, A square, let us calculate, which is what? Row 1, column 1, 0, 0, 1, 1. Row 1, column 2, 0, 0, 0. Row 1, column 3, 0, 0, 0. Right? Row number 2, column number 1, 0, 1 into 0, 0, 0. Row number 2, column number 2, 0, 1, 0. If you add these three, you will get 1. Then you are going to get 0, and if you solve it, it is pretty obvious to me. This is 0, 0, 1. So basically, A square is identity matrix. If I say that A power 4, that this is A square into A square is identity, identity multiply identity is identity only. So remember, identity power n is identity. That means you multiply identity matrix n number of times, you will get identity. Remember that 1 power n is 1, no? Identity power n is I. So final answer of this question is option C. Okay. All right. Understanding it. Shall I move towards the next thing, which is some ninja technique? Okay. This is something really, really interesting. Suppose you are given with a diagonal, diagonal matrix which is and you have to calculate a raised to power 200. This is your question. Here comes your savior, Ninja Ma'am. Okay, because see, a raised to power 200, who will calculate so many matrix multiplication, right? So understand, what is the ninja technique? Suppose a diagonal, this is applicable only for diagonal matrix. A is equals to diagonal of any matrix. So a raised to power k, if you calculate, so you just have to raise the power of each element in the diagonal by that power, okay? So a power 200. So right now your A is what? 2, 3, 5, correct? Rest every element is 0. Yes, this is your A matrix. Now you want A raised to power 200. This is going to become what? 2 raised to power 200. 3 raised to power 200. 5 raised to power 200. Rest every element is 0. So basically your A power 200 is going to become diagonal matrix only. If A is diagonal, then A raised to power k is also diagonal, right? And here is the shortcut. That's how you calculate the value of A raised to power k. Next time, don't forget, don't panic. You'll be like, oh, in the exam, KCET examination now, students who are not attending this lecture, they'll be like, A raised to power 200. I think I should leave this question. Very less students will think, okay, this is the easiest of all. Let me just grab this opportunity, do this question, okay? All right. Yes, so this is how it is. And now we will talk about another topic, which is transpose. What is a transpose of a matrix? Okay. Okay. Is it recording? Okay. All right. So transpose of a matrix, very easy. Okay, so suppose I take a matrix right here. A is suppose 2, 3, 5, 0, 1, 3. Okay, this is a 2 row and 3 column, 2 cross 3. Now A transpose will be a matrix which is 3 cross 2. It will flip, number one thing. Because in transpose what happens, row becomes column and column become row. So over here, this row 1 which you are seeing right here, it is going to become column if I take transpose of this. So 2, 3, 5, which is right now is a row, it will turn into a column 2, 3, 5, and row number 2 which you can see 0, 1, 3, it is becoming column number 2. And same, if I talk about column number 1, 2, 0, now column number 1 can you see is beautifully becoming row number 1. Column 2 is becoming row 2. Column 3 is becoming row 3. So this is how it is. The row and column interchange we call it as. Okay. So and if you take again one more time, if you just take transpose of A transpose, you will get back to this. Okay. So this here comes the property. A transpose. If you take one more transpose, back to basics. Okay, this is how your transpose works. Also, the notation is A T, like T is on superscript. You can also find A dash is also nothing but A transpose. Okay, one more notation. Now, some properties, again, the very first property, A transpose, one more transpose will give you back to A. That is first thing. Second one is kidnapper's property. I will call it as a kidnapper's property. Okay, so kidnapper's property means that sometimes it happens now that usually in movies it happens in movies or maybe in crime series that okay, So what I have done is this is Ka whole transpose, okay? So I have this K is stuck. This K is a kid who is stuck inside this bracket. He wants to get out of it. And then eventually the kidnapper realizes, so obviously if somebody wants to get out of a kidnapping, he has to pay some ransom amount, right? So he wants to get out, but can you see he gets out of this transpose and he has to pay no price. This K is like free. Okay, so K is free, only the transpose is on A. So K is just like this. What does that mean? That kidnapper has kidnapped incorrect person. Okay, so it happens sometimes. Pata chale. So it happens that kidnapper was assuming, oh, he's a rich kid and eventually he was like, oh, lower middle class. He was like, kidnap me. I don't have anything. Kidnapper has to leave that poor guy, like nothing will I can ask from your parent. Go, like that. Okay. So this is that property, kidnapper's property. Okay. So any constant which is stuck inside this transpose, it will come out just like that, free. Okay. And again, one more property. Suppose you are having a summation of two things. Suppose A plus B transpose. Okay, so it is going to become A transpose plus B transpose. And same goes with minus. Now, this is the property which is very, very important, guys, which is AB whole transpose. Now, understand, AB whole transpose is equals to B transpose A transpose. This is a reversal property. Okay, reversal property. Suppose you are having two things, ABC whole transpose. This is very important. Very important for KCET. We'll use it right away. ABC whole transpose. So this will C transpose, B transpose, A transpose. Okay, so reversal property is happening over here. Okay, and also one more thing which is very like quite intuitive. See, understand what is happening. Suppose you are having a matrix A which is 2, 1, 0, 3 and A transpose. Can anybody tell me what will be the A transpose? So ma'am, 2, 1 is row 1. So this is 2, 1, 0, 3, 0, 3. Now can anybody tell me what is the trace of this A? So ma'am, trace of A is 2 plus 3, 5. And trace of A transpose is also 5 because see, diagonal elements are not changing. Even if we are taking transpose, even if we are interchanging row, interchanging columns, what is happening? The diagonal elements are still the same. So that is why trace of A is actually equal to trace of A transpose, guys. Okay. Are you getting it? Are you understanding it? I hope that this is clear. And now we will talk about this question, which is this, okay? KCET 2021 PYQ. All right, let us understand what this question has to say. So this question is saying, A matrix is given and B matrix is given. We need to figure out AB whole transpose. Now there are two ways to go about it. Very basic way is calculate A into B. So you want to calculate A into B just like this. 1 minus 2, 1, 2, 1, 3 and 2, 1, 3, 2, 1, 1. Just calculate. No use of property, nothing. Just AB calculate, then take transpose now. So this is row number 1, column number 1. 2 ones are 2, minus 6 plus 1. 2 minus 6 plus 1 is going to become minus 3. Correct? Row number 1, column number 1. Row number 1, column number 2. 1 minus 4, 1. So this is 1 minus 4 minus 1. So minus 4 plus 2 is minus 2. Now row number 2, column number 1, right? So this and this, 2 2s are 4 plus 3, 7 plus 3, 10. And this is your 2 plus 2, 4 plus 3, 7. This is AB. Now you are looking for AB transpose, right? So this is minus 3 minus 2. See, row 1 is becoming column 1. This is 10, 7. This is matching with which? Tell me. Minus 2, 7, 10, 7. I can see that this is matching with option B, right? Minus 3, 10, minus 2, 7. Option B is absolutely right. Direct question. Can you see the level of KCET? Are you getting that confidence? I hope you're getting that confidence, right? Okay, now symmetric and skew. Oh, this is very, very important. This topic is very important, guys. Symmetric and skew symmetric matrix. Okay. All right. So symmetric and skew symmetrics. Let us understand A transpose. Okay. If a matrix is A whose transpose is A transpose, and if they are equal, it happens sometimes. Sometimes you are given with a matrix and you calculate its transpose and you're like, huh, no change, same to same. Same to same means that is a symmetric matrix. Okay. And if you have a matrix A and if you take a transpose and you'll be like, huh, they are same, but the values are opposite sign, just that difference. So A transpose is equals to minus A, that means skew symmetric matrix. So this is a basic definition, right? Symmetric means A and A transpose are same. Skew symmetric is A transpose is equals to minus A, guys. And one by one we'll understand the symmetric and skew symmetric. Now you know the definition. So symmetric, where A transpose and A are equal. Okay, so suppose this is the matrix, right? This is your A. Okay, A transpose. Let us calculate A transpose. So 2, 1, 3. Can you see this is row number 1? 2, 1, 3, column number 1. While taking transpose, row number 2, 1, 0, minus 2. 1, 0, minus 2, 1, 0, minus 2. Okay, then 3 minus 2, 5. And now just look at it. Just look. Look at their faces. Can't you see twin brothers? Huh? 2, 1, 3, 2, 1, 3, 1, 0. How is that happening? What is so special about this matrix? I mean, even if I take transpose, it is not changing. So the special about this is, so you don't have to actually calculate A transpose and then compare. You can directly see this. I can directly see this. I don't have to calculate. And I can just tell this. That remember that old uncle comes at our place and just by looking it, they can tell you, this child is very studious. This child is very naughty. Just like that. I am that old uncle. I can just see the face of this matrix and tell you whether it is symmetric or not. How? Just give me a moment, okay? So understand. This is a diagonal matrix. I am not interested in that. I don't care what is this. But can you see this is 1 and this is also 1. These two are actually conjugate elements. What are conjugate elements? That means, see, this is sitting in first row, second column. This is second row, first column. A21, A12, A21, conjugate. They should be same. Then again, can you see A13 and A31? Again, conjugate elements are same. And minus 2, minus 2. Can you see it? This is A23, A32. These two are also same. So when conjugate element Aij and Aji, basically these two should be equal. These two should be equal. See, this is equal, and this is equal. Diagonal, I don't care. So the moment I'll see this, you are symmetric. I know that. You are studious. I know that. You're naughty. I know that. So this is a studious kid. Okay. Alright. Symmetric means studious. Now old uncle will come and old uncle will recognize skew symmetric also. First of all, I'll show you A transpose. Okay. A transpose. So again 0 to 4. 0 to 4. Minus 2, 0, minus 3. Minus 4, 3, 0. Can you see now this and this? Compare. So ma'am, 0, 0 matching. 2 minus 2. Okay. That means this is negative. 4 minus 4. They are looking same, but just that minus 2 to 2. 0 to 0. Minus 3, 3. Minus 4, 4. 3 minus 3 0, 0. Basically everything is negative. Right? So A transpose is equals to minus A. This is your minus A basically. This is what? Your minus A, right? So this is skew symmetric matrix. Now how to identify, just like the old uncle looking into eyes? You are naughty. Okay? So in skew symmetric, I am concerned about diagonal. The very first identification of skew symmetric matrix is diagonal elements should be 0. Otherwise it will not work. Diagonal has to be 0. Clearly, diagonal element should be 0 and the conjugate element, can you see again, by looking at this, I don't have to check transpose. By looking at diagonal should be 0, 1 second check should be that conjugate elements should be equal but opposite in sign. So 2 minus 2. Then minus 4, 4, whatever it is, equal but opposite in sign. 3 and minus 3. Then now this is the identification of skew symmetric. Okay, all right, clear. Okay, so I think this is clear now, and now we can talk about how much is pending. Symmetric is there. Okay, I don't think so very. Okay, so 2 more topics are pending. Symmetric and then inverse. Okay, all right. So how to identify whether a matrix is symmetric or skew symmetric? So this is a question, this is not, by the way, this is not MCQ. This is a question which has 4 parts. 4 questions are there. We have to solve each and every. This is not something which is A is correct, B is correct. No. See, if A is a square matrix, that which of the following statements are correct? So one by one we have to understand. So first is A is a square matrix. Okay. Which of the following is correct? Okay, all right, A is a square matrix. So see, first option A they are saying is we need to check whether A plus A transpose is symmetric matrix or not. Okay, so what I'll be doing is whichever matrix is under that scrutiny, we have to check now. We will take it as another matrix, let's say X. X equals to A plus A transpose. We need to check whether X equals to symmetric, na? X, if X is a symmetric matrix, then this should be correct. We need to check for this. Okay. So X transpose is A plus A transpose. Remember the properties of transpose we have studied. So X is this. Now I am taking transpose on both sides. Taking transpose on both sides. Okay. I need to calculate X transpose. Okay. So X transpose is equals to A transpose plus A transpose, one more transpose. Remember that property A plus B transpose is A transpose plus B transpose. Same. A transpose plus A transpose transpose. So X transpose is equals to A transpose plus A. Right? A transpose plus A is actually X only. Can you see? So that means yes, X is a symmetric matrix. Option A is correct. That's how you have to solve. Option A is correct. Now option B, A minus A transpose is skew symmetric matrix. So option B, Y is equals to A minus A transpose. So if Y is a skew symmetric matrix, so we have to check. Y transpose is minus Y. Okay, so again, taking transpose both the sides. Y transpose is A minus A whole transpose. Okay, correct? Y transpose is again A transpose minus A. Take minus sign common. You will realize this is A minus A transpose. Now A minus A transpose is Y. So can you see minus is there? This is Y. So Y transpose is coming out as Y. So hence yes, it is skew symmetric. It is not symmetric. Skew symmetric. So that means B option is also coming out as correct. Are you getting my point? Yes? Alright. Option C, A transpose is a skew symmetric matrix. Option C, A transpose. So let us just mark it as Z. Skew symmetric. So skew symmetric means Z transpose is minus Z. Skew symmetric, right? Not the symmetric. Yeah, A transpose. Correct. So here have this we have to check. So let's take transpose. Z transpose is A transpose whole transpose. We are taking transpose both the sides. Now understand reversal law will come into the picture. 100% attention over here because this might be a little confusion. See, remember AB whole transpose was B transpose is A transpose. So A transpose whole transpose will be this transpose, this transpose. So A transpose, this is B, right? So B transpose and then A transpose. So what is this? Tell me. This is ma'am A. This is A transpose. Transpose is what? A transpose is your Z transpose. Can you see this is back to Z? Z transpose is equals to Z. That means this is a symmetric matrix, not the skew one. No, no, no. This is symmetric, not skew symmetric. Negative sign is missing, right? So it is not at all a skew symmetric matrix. Wrong. Option C. Okay. And what about option D? This is quite verbal. I don't even have to like pick a pen to solve option D. Trace of a skew symmetric matrix is 0. Ma'am, skew symmetric matrix. Hold on. You just told us about the diagonal of skew symmetric. You told us diagonal of skew symmetric matrix is always 0. All the elements of diagonal of skew symmetric matrix is 0. That is why trace of skew symmetric matrix is 0. That means option D is correct. So only option C is incorrect. Rest everything A, B and D are correct. So with this question, I think your basics of symmetric and skew symmetric are clear. If you have listened to that topic nicely, then your basics, I believe, are clear and you are ready to solve everything. Before, one more, before I just give you a question, I just want you to give one more property, okay, one property, very important, which is this. How can I forget, okay, which is this. A raised to power n transpose is equals to A transpose raised to power n. Basically, whenever you have any power on your matrix and there is a transpose, that power and transpose are interchangeable. Okay, one more property, okay, properties of transpose. So this is what I have to tell you last about this, and here I will give you the same thing, same problem over here, which is this. Let us understand what this question has to offer. Let A is a skew symmetric matrix. What does that mean? That means A transpose, whenever will be required, we will write it as minus A, because it is given. A is a skew symmetric matrix. This is the definition of skew symmetric matrix, right? Now we are looking for A raised to power 2021. So A raised to power 2021, either it is symmetric or skew symmetric. Row column, it is not making any sense. So A power 2021. We need to check whether this is a symmetric matrix or skew symmetric. I have told you, whenever you have to check any matrix, whether it is symmetric or skew symmetric, what you have to do is take it another matrix X. Okay. Now we need to check for the X transpose, taking transpose both the sides. Let us check what is there. Whenever I take transpose, what is there? Okay. So this is A raised to power 2021 transpose. Now I told you that property, that power and transpose are interchangeable. So it will make sense if I just write it this manner. A transpose I can write directly as minus A. Power is already odd power. 2021 is odd number. Minus having odd power is giving you minus A power 2021, and A power 2021 is X. So X transpose is equals to minus X. X transpose is coming out as minus, this is X, right? Negative. X transpose minus X is clear-cut indication of, clear-cut definition of skew symmetric. That means option D is absolutely right. Okay, clear? I guess this is done. And now we are going to move towards next set of two questions I have, which is this and this. Okay, again for symmetric and skew symmetric, I told you very important topic for your KCET 2025. Okay, so yes, if A and B are square matrix of some order and B is a skew symmetric, that means B transpose is minus B. Then A dash B A, that means A transpose B A is what? Symmetric, null, diagonal, skew symmetric. Okay, so again I told you that you have to take this as X. Now you have to take transpose on both the sides. A transpose B A, take transpose. Now reversal law will come into the picture. X transpose is equals to, now reversal law, A transpose, then B transpose, then A transpose, one more transpose. So this is A transpose as it is I am keeping. B transpose is minus B, and A transpose becomes A. So this is minus A transpose B A, which is back to X minus X. So X transpose is coming out as what? Minus X. X transpose coming out as minus X, skew symmetric matrix. Now you know the algorithm, right? Now you know every time somebody asks symmetric, skew symmetric, you have a step by step. You can't just sit and think. First step is take X. Next step is take transpose. Then solve it using properties. Eventually think X transpose I am getting what? X or minus X. If getting X, symmetric. If getting minus X, skew symmetric. Okay. Fear not when Ninja Ma'am is here. Okay. All right. Yes. See, if you attend, I know that you guys watch at 1.5x. It's fine, but don't skip anything, because I'm not a very verbose person, like verbose as in I just don't talk randomly. Okay, so I just, whatever I'm telling you in this session, everything is important. It is a already very crisp session, so just don't cut and forward it. Okay, because I know some people are having that habit. Okay, now singular versus non-singular matrices. This is again another definition. Singular means determinant 0, non-singular means determinant non-zero. Understand? So singular means determinant 0, and non-singular means determinant non-zero. Understand? Okay, singular means determinant 0, non-singular means determinant non-zero. Non-zero. So whenever somebody tells you that determinant is 0, okay, yeah. And now you must be wondering that, ma'am, what is a determinant, how to calculate? So determinant of a 2 cross 2, let me tell you. Determinant of a 2 cross 2. So I already told you determinant is a value A, B, C, D. This is your determinant. This is not the matrix. This is your determinant. Let's say delta. So value of delta determinant will be AD minus BC. Okay. A into D, AD minus BC. Okay. So yes, this is a proper terminology right now, and you can just solve again another KCET question based on this thing, which is, if A is this is a matrix. Now this is a singular matrix, means determinant of A is equal to 0. Singular means equal to 0, non-singular means non-zero. Okay. So determinant A equal to 0. So again this multiply this. So 2 minus K, 3 minus K, minus 2 into 1 equals to 0. Or you can say that 2 minus K, 3 minus K is equals to 2. So this is obviously a quadratic equation. This is going to give you K square minus 5K plus 6 minus 2 equals to 0. K square minus 5K plus 4 equals to 0. From here, K value will be equals to, if you just solve this, K minus 4, K minus 1 equals to 0, K is equals to 4, 1. So finally you will get 4, 1. Okay, so K is 4, 1. Now what do you want? You want 5K minus, oops. No need to do this. No need to do this at all. Understand what they are asking. 5K minus K square is something they are asking. They are not talking about the value of K. So what we are going to do is K square minus 5K plus 4 equals to 0. 4 will stay here, rest everything will go there. 5K minus K square will go there. So 5K minus K square is clear cut 4. Option D is absolutely right. Okay. If they would have asked you the value of K, we would have told them. Right or wrong? Okay. So I think we are done with this as well. And I think the last topic. See, there are a lot of topics which you might feel that like are not covered, just like adjoint and everything, that we will cover in determinants. Okay, so determinants is pending. So to introduce adjoint, to introduce a few things, I need the base of determinants. So that will be, we will be covering inverse, also will be covering full-fledgedly in determinants chapter. But now, right now, I just want to give you one thing, which is inverse of a 2 cross 2 matrix is something which I would like to give you. Now, what is an inverse? Understand. See, inverse of a matrix. Inverse of any matrix, suppose inverse of a matrix B will be A if AB and BA will give you identity. Okay, so suppose I am giving you a matrix B and I am asking you B inverse. Okay, B inverse will be a matrix A, first of all, which will satisfy this thing that whatever I multiply with, so that, see, okay, so B is a matrix. Okay, I want inverse of that. So if I multiply inverse of that matrix, what I will get is identity matrix. So this B inverse is that matrix which I multiply with B, you will get identity. So this A is what we are looking for. Somebody asks you that find the inverse of B. So you are looking for that matrix which you are going to multiply with B matrix, you are going to get identity. Or you can pre or post multiply, both are same, AB or BA, both should be identity. This time AB and BA both should be equal. Okay, this is what we call as inverse of a matrix. Okay, there is a full-fledged formula for A inverse, which is adjoint A upon determinant A. Okay, adjoint A we will be understanding in the determinants wala lecture. That is one thing. And also inverse of a matrix only exists if your determinant A is non-zero. Determinant. So if you are talking about inverse of A, right? If you are talking about inverse of A, so determinant A should be non-zero. If determinant A becomes 0, then inverse of that A matrix will not exist. Same goes for B. And also, if you are saying that A is the inverse of B, that means B will be the inverse of A. Basically, A and B are inverse of each other. Okay. So very first thing is condition of inverse. Condition of inverse is determinant A not equals to 0. Inverse of A. So if you are looking for inverse of A, the very first thing you should look for is determinant A not equals to 0. That means A is a non-singular. A should be non-singular. Otherwise, inverse will not exist. A should be non-singular matrix, right? If it is 0, then just don't talk. Okay? Alright. Now, there are some properties of inverse. Before I go and tell you how to calculate inverse of a 2 cross 2, before I give you the actual shortcut of 2 cross 2, let me just give you this property of inverse. Just like property of transpose, A inverse is back to A. First thing. Okay. This we will cover in determinants lecture. Now, A transpose inverse. Transpose and inverse are also interchangeable. Remember, I told you this property A power n power transpose. This is A transpose n. Same property. And also, remember I told you AB transpose, reversal law, B transpose, A transpose. It is same as follows in inverse. AB inverse is B inverse, A inverse. Okay. Now, inverse, now there are some ninja shortcuts. Okay, some ninja techniques. Inverse of a 2 cross 2 matrix. Suppose you are given with A matrix, which is 2, 1, 3, 0 or 3, 9, 3, 7. And you're looking for A inverse. Okay. So A inverse will be what? So for A inverse, you have to calculate. You have to just interchange. See, interchange the diagonal elements. Trick is interchange the diagonal elements. Okay. So 2 and 7 are interchanged right here. Okay. And this is first thing. Second, non-diagonal elements, you don't have to interchange. You just have to reverse the sign. So 1 and 3 will be at same place but sign reversal. So reverse the sign of rest 2 elements. This is only for 2 cross 2. Reverse sign of remaining elements. non-diagonal. Okay, and also don't forget that you have to divide it by determinant of A. So 1 upon determinant A. 7 2s are 14 minus 3. 14 minus 3 is what? 11. 1 by 11. So this is your, what we call it as inverse of a matrix. 2 cross 2 matrix. This is the shortcut. Okay. Alright. Okay. And yes, let's do a few questions based on that. Okay. Few KCET questions before I leave. So I have how many questions? 1, 2, 3, 4. 4 questions back to back. Are we ready for it? Are we up for it? Okay. 3, 4 questions back to back. Okay. So yes, now they are saying in this question, understand, there is a matrix. Let me mark it as B. B into A is equals to identity matrix. Can you see this is BA is equals to identity? If BA is identity, that means A and B are inverse of each other. Yes or no? So that means you are looking for B. So you're looking for actually, what are you looking for? Tell me. You're looking for A, right? Matrix A. This is A. You're looking for A. Right? A is question mark. Clearly, A and B are inverse of each other. Okay. So you're looking for inverse of B actually. So you're looking for inverse of this. So yes, inverse of this will be what? I told you how to calculate inverse. So first of all, inverse of this. Diagonal elements you have to change. So 2 and 2, if you will interchange, it will not get affected. Still 2, 2. And you have to change the sign of this minus 1, minus 3. And now you have to divide it by determinant. 2 2s are 4 minus 3. So 4 minus 3 is 1. So clearly 2 2 minus 1 minus 3, option B is absolutely right. Yes or no? Yes, option B is absolutely right. Okay. So 2 2 minus 1 minus 3. Easy question. I think within 10 seconds you can do this, right? And the next question is also about inverse of 2 cross 2. So this shortcut will come into the picture automatically. Okay. A is this and AB is I. The moment you see AB is I, that means A and B are inverse of each other. They are talking about B. That means they are looking for A inverse. To calculate A inverse, again the shortcut will be applicable. So you have to interchange 1, 1. So anyway, interchanging will not give you any kind of change. And you have to reverse the sign of non-diagonal. So minus tan alpha by 2 will happen and this is tan alpha by 2. And also let's not forget 1 upon determinant of this. Determinant of this, okay. So determinant of this will be what? 1 minus tan square alpha by 2. But since this is a negative sign, so 1 plus tan square alpha by 2. 1 plus tan square is what? Sec square alpha by 2. It will go up. It is cos square alpha by 2. And this is 1 minus tan alpha by 2. Tan alpha by 2, 1. Now let's match. Cos square alpha by 2 is already there in all 4 options. We just have to understand whether we are having the matrix A, I, A transpose. Okay. Also, this is wrong. A, I, A transpose. Is this A? Can you see? This is not A. Because A is having tan alpha by 2, we are having minus alpha by 2. A though is definitely not there. Option A is wrong. Is this identity? Not at all. Identity is not doesn't look like this. Is this A transpose? Okay. So let us understand. This is your A. If you try to take A transpose, it will become 1 and tan alpha by 2 should lie over here. And minus tan alpha by 2, 1 should lie over here. So clearly this is your A transpose cos square alpha by 2. This is your A inverse, guys. Again, same question with the shortcut. Just a little bit effort was required to recognize, to identify which option is correct. But yes, I don't think so. This is a very, very difficult question. Now, 2 questions are left, which is, okay. This, I want to do this question. Only one question. Yes. A is this, then the inverse of matrix A cube is what? Inverse of A cube is what? Okay. So I think I can give this as a homework. I want to give this as a homework. Hint, I will give you hint. Hint is, first of all, calculate A square. Okay. calculate a square. And then, first step, then calculate a square into a. Okay. So again you will get a 2 cross 2, and then third, take inverse up using shortcut. Okay. So inverse, so you get this a cube, and then now you have 2 cross 2. Now take inverse using that shortcut. Okay. Okay. Okie dokie. All right. Perfect. Now, one more thing I would like to tell you. You guys are having any doubts, you know what to do. First thing, subscribe to our Vedantu Karnataka channel, Telegram channel. Link is already given, but my personal Telegram, you will not find link. You just have to search it, t.me/Namrata. It is a little big. Please mind the spelling. Jaisinghani. Okay. Just stay connected. t.me/Namrata Jaisinghani, Jaysinghani. Okay. So I guess on this note, we are winding up. PDF you will get on the Telegram official Vedantu Karnataka Telegram channel. So do subscribe, do check out, and in case of any doubts, comment. I will be more than happy to reply. If not comment, you can just connect me here. Okay, alright. This is me, your Ninja Ma'am, signing off. I'll see you all in the next session.